All right, so to solve these initial value problems, you'll see these on the final exam, and the big challenge is knowing when to integrate, because a lot of times students see this and they're like, I don't know where to start. Like, what am I supposed to do here? So here is the deal with this question. When you look at what is given, you are given a derivative. And I know this is typed up nicely, but I just want to write it out because it makes me happy to write it out. So we're given a derivative. All right, that's the key critical information that we're given. We're also given this f of 0 is equal to -2. The fancy phrase for that is known as our initial condition. The reality of this is this initial condition is going to allow us to solve for our plus c. So that function information is going to allow us to solve for the c value. So up to now, we haven't been solving for c, but now we can solve for c given this function information. So here's what the deal is. We're given the derivative, and what they're asking us is to find the original function f. So we want to go back and find our function f of x, the original function. So the whole deal is the antiderivative is the opposite of the derivative. So the way that we're going to go from the derivative backwards to the original function is by integrating. So that is our very first step, is recognizing that this is in fact an integration problem, and it's an integration problem because we were given a derivative and we need to go back to that original function. So step one is going to be to integrate, and we're just going to integrate the derivative. So my derivative is given as follows: f prime of x is equal to 2x squared plus 4. Now, what we're going to do is we're going to integrate both sides. So we're going to take that equation and we're going to apply an integral and a dx, an integral and a dx. So both sides are going to get that integral dx bookend expression. Remember, the integral and the dx go together forever. You don't just write some random integral sign, you also put the dx in there. Okay, then we're going to use our critical thinking skills, specifically what we learned on the previous page. On the previous page, we learned that anytime we have an integral of a derivative, those are opposite operations. And because they are opposite operations, they are going to cancel out. Now, remember that the integral sign is also attached to the dx. So when the integral sign cancels out with the derivative, it's not just that integral sign that's canceling out, it's also the dx that is canceling too. So basically the integral, the derivative, all of that notation is gone. They're going to undo each other and leave us with just little f of x. Now, on the right-hand side, we have these two terms. We're going to integrate just like we normally would. The 2 is going to take along. We're going to add 1 to the exponent, divide by the new exponent. The plus 4 will go to a, now here's the deal, it's a standalone constant. That standalone constant, because we're anti-differentiating, we're going to add on to it and it will become 4x and then the plus c. Now, sometimes students want to put a plus c here and a plus c there and a plus c everywhere. No, we are only putting one plus c, only one plus c per problem. So we don't need a plus c over here and a plus c here. We just tack the plus c on at the end. All right, now before what we did is we just kind of stopped the boat there and we said, okay, this is our answer. Now, however, because we have this initial condition, we can actually solve for the plus c. Now, this in general, or this is called the general solution, and it's general solution because you just have this random plus c. But if we want to find what we call the particular solution, we can find that c value. And here's how we find the c value. We use the initial condition. So this f of 0 is equal to -2. Now, remember that when you're talking about f of x, whatever's in the parentheses, that is your x value. So the way we're going to use this initial condition to find c is we're essentially going to start by plugging in x is equal to 0. So we take our general solution, and everywhere that we have an x, boom, 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 here we have these x's, we are going to plug in 0. So we're going to have f of 0 is equal to 2 times 0 to the third over 3 plus 4 times 0 plus c. Now, you might ask, why is that going to help me? How is that going to help me? The thing is I'm trying to solve for plus c. I also know that f of 0, this is a little tricky, f of 0, if you look at this f of 0, it is equal to negative 2. So what I can do on that left-hand side is I can plug in the negative 2. So this is going to give us f of 0 is negative 2. And then on the right-hand side, we have 0. That's going to cross out to 0. Second term crosses out to 0. And that gives us c is equal to negative 2. Now, you don't just stop there. What you then do is you put these two together. So you have your function, you now know the c value, and so our third step is to combine parts 1 and 2. So we'll write it as f of x is equal to 2x cubed over 3 plus 4x, and then we'll plug in that c value is negative 2. And that is our final answer. That's our original function that would satisfy that initial condition. And mathematicians call this the particular solution, particular because it is for that particular c value.